What are you having, Alison?
Rice
Don't tell
and
her.
spam.
Ooh,
Wait.
yes.
Ooh.
That's delicious.
Looks pretty good.
Yeah.
Coffee.
Thanks for
I
sharing.
woke up, so I need to wake up, you know.
TF, TF.
So how's everyone's day going on?
Pretty good, pretty good. Just
Pretty good?
finished some midterms and exams, so
Okay.
pretty stress-free this week.
Uh,
Mine just started.
Good luck. Don't
well, I
need to.
mean, I have like next week I have another exam,
Me too.
midterm. Yeah.
Yeah, I have to.
What about you guys?
Yeah, we have exams. Well, I just finished mine this week. Some of you guys have exams coming soon. Hey, Cameron. Can you hear us? This is Kameron Larsen, our guest speaker today. He's taking a quick break from work to swing by and talk to us about his work. Hey, Cameron, I think you might be muted. We can't really hear you. Awesome. Hey, Cameron.
Hey, Justin, how's it going? Hi, everybody.
It's going good.
Hello.
So like I said
Hello.
earlier, this is Kameron Larsen. He's my mentor at JPL, and he's here to talk about his work, his time there, and some suggestions he has for possibly working there.
Yeah, sounds good. Just so you guys know, I'm working from home, and my wife and 2-year-old child are currently at the grocery store, and they'll be returning any minute. So there might be some disruptions, but that's what remote work is like. So first of all, I didn't prepare a slideshow or any pictures. I've been extremely busy at JPL, and this is something that the work at JPL is often like. I've worked there since 2008. I started as Justin is currently working as an academic part-time is what it was called back then.
Mhm.
And I worked as an academic part-time until 2012 when I graduated from Cal Poly. And then I started full-time. So I've been full-time since December 2012. It's been a long time. During all of that time, I worked on quite a few different projects, ranging from world-class atomic clocks to gravity sensing, on the moon, around the Earth, to radio occultation measurements for weather prediction. Most of my work focuses on software development, a little bit of hardware design, schematic design, and PCB layout, as well as FPGA programming. So I know this is the robotics club, so I unfortunately don't have too much mechanical experience, but I guess I can talk to the software / electrical side a little bit. I guess I just want to also let you guys know that since this is quite informal for me, I just want you to be able to ask questions, or if you have any thoughts, just let me know, because I think it would be better if this was a little bit more interactive.
Yeah, we set it as a Q&A, and I've told them that we won't really have slides prepared, and that's perfectly fine as well.
Okay, sounds good.
Yeah. So I guess we can start off with like some of the projects you mentioned, like you mentioned gravity sensing instruments and some projects with the moon. Do you want to go more in depth with that, talk about that more?
Sure. So
Current projects or former projects, up to you.
yeah, let me recall in my mind. The project that I started working on when I first arrived at JPL was called Grail. And all NASA and JPL projects have these, acronyms that it's very hard to remember. But that one was something about gravity reconnaissance, something lunar. It was about sending 2 satellites to the moon to orbit the moon for a few months and precisely measure the gravity of the moon at different locations as it orbited around the moon. The way this works is you have these 2 satellites, let's see. And as they orbit, let's see, here we go, zoom. My head is the moon. As they orbit around the moon, there's different features inside the moon as far as density and mass and mountains and things. There's not really mountains on the moon, but there's holes in the moon, and there's lava tubes and different density. So as it orbits, this one might get pulled towards the more gravitational heavy thing. So there's a separation that occurs, and then this one gets pulled, and so there's, it comes closer together, and then it returns back to its normal separation. So you see these blips of where the separation increases, and then it decreases, and then it returns back to normal. So that's how we map the gravity. The way the sensing occurs is using Ka band radar to send a pseudo-random code along with the carrier between both satellites. It's called dual one-way ranging. And we're able to process the pseudo-random code that we receive on one side, and we can then know exactly, because the code is pretty long, we actually know exactly how far apart we are to within the code chip width. And the code width was something like 1 megahertz or something like that. So that gives you about 1 microsecond resolution. And then to get even better than that, you use the carrier phase. So the carrier at Ka band is very, it's a very high frequency. So we can actually get very, very good resolution to within 10 or 100 nanometers, even though these 2 satellites are hundreds of kilometers apart. So that was called Grail. The other one that we worked on was bringing it back home to the Earth, where we created the same thing, but I worked on a technology demonstration. This one's called Grace Follow-On. The technology demonstration was called LRI, the Laser Ranging Instrument. And it used lasers and optical cavities to do the dual one-way ranging instead of, well, it also did the Ka band radar, but we also added the lasers, and that got us better resolution to within nanometer level precision.
Is this something similar to Lidar?
Yeah, it's somewhat similar. Let me think for a second. Lidar is one-way ranging. So you're actually looking at reflections coming back to you. The dual one-way ranging is where you're not actually sending from one to the other and back. You're just sending it both directions. And because there's content encoded on the actual signal, you can actually determine the time of flight distance. But for Lidar, it's typically time of flight where you're sending it somewhere and then bouncing it back, and you calculate how long that would actually take light to travel. But for us, we're not doing a time of flight calculation. We're doing more of a carrier phase measurement.
I see. Very interesting though.
Yeah, thank you.
We have a quick question in the chat. William asks, have you worked on this project in person? If so, could you describe the workflow and the environment?
Yeah, working at JPL is really awesome. One of the coolest parts, and Justin can probably attest to this, but one of the coolest parts about JPL is just being surrounded by all of the wonderful people there. Everybody is very kind and very knowledgeable. You have wonderful people that are willing to take time out of their busy schedules to help you and to teach you new things. Everyone tries to work together to a common goal, whether it be the project or the goal of the lab. So working on Grace Following was really fun. We had a team of about 5 core engineers. And what was cool is we were all about the same age. So we would even hang out after work, go mountain biking or go get dinner and things. But yeah, it's a really good environment. As you run into problems, you can walk down the hall to your colleague's office and just say, hey, what's going on? I have a quick question. So yeah, it's a really good environment. Do you have any specific questions about it? Let me see, I actually can open chat here myself.
Yeah, just like how different teams collaborate with each other. Like you said, you mentioned something about the software and the code and how it's, you know, extremely long and tiresome. So I would assume that, you know, you have different teams for that. Like how would they work with each other in that kind of setting?
Yeah, so there's actually a few different ways this can work at JPL. Within our section, we pretty much do we're an instrument section where we build instruments. That means we design them from the ground up. We design the hardware, the schematics, we design the PCBs, we design the code, the FPGA bit streams, we design the science concepts. So that's one way of doing it, where you have within your group, you have all of the disciplines working together. And I think that's the same that you guys do at the robotics club. You have electrical engineers, you have mechanical engineers. Only for us, we actually outsource the mechanical engineering to the mechanical engineering section, but we have all the other disciplines working together. So that's one way to do it. The other way is there's also sections and groups at JPL that are really specialized. They only work on one thing. There's the FPGA section that just does FPGA work. There's the flight software section that only does flight software. And for some projects, they prefer to manage them where they actually contract out the work to those different sections versus doing it all in-house. I prefer to do it in-house because that gives you the employee an opportunity to learn different fields and kind of expand the things that you know, versus if you were in the FPGA section, you're only going to be working on FPGAs for the rest of your career.
I have another question. Oh, sorry. First, let me answer the question in the chat. So, JC asks, "What's your favorite part about working at JPL, and how long have you been practicing programming? And what would you recommend practicing in order to consistently progress?"
Okay, yeah, I just saw that question myself. So, I guess I'll start with the programming questions. I've been programming for a very long time.
Yeah.
I think I started learning the C Bible, also known as the Kernighan or KNR, Kernighan and Ritchie. These guys invented the C language. It's just called C, and it's just a small book. But he gave me that when I was like 8. And I started looking at it and trying things out. I remember running GCC when I was like 9 or 10, and for the first time and compiling a Hello World program. So I've been practicing for a very long time. Actually, my brother, who is a little bit younger than me, got more into the side of web development. And when he was 16, his friends came, he has a couple really close friends, and they kind of peer pressured him into getting a job. They said, Kyle, like, we've been working for a year. They've been working since they were 15, and you've never had a job. Like, you should get a job. And he said, fine, I can get a job anytime I want, watch. And so he went on Craigslist, and he found somebody asking for help doing web programming for, like, it was a payroll company. And he said, we're hiring somebody to do web programming. And he applied and he got the job. His very first job was actually working for like a payroll company doing programming. But yeah, so both of us have been, learning for a very long time. As far as practicing, these days there's amazing resources. There are so many good websites and tutorials. There's like REPL, I think, is the website that you can actually go online, type your code, and compile it all online without ever having to leave the web browser. These resources are extremely important to use, and I think having the ability to get quick feedback on the changes you're making is really what helps you progress. You can read all the texts in the world, but unless you sit down and start writing the code and compiling it yourself and seeing what changes do what, then you're really not going to be able to learn it completely. So that's one way that I recommend to practice is sit down and come up with, you know, a challenge. Come up with a challenge, a project that you want to make a game, or maybe you have an Arduino, or maybe you have a Teensy and you want to program that to do something. Come up with something that you want to do. For example, like, you know, I work all day on electronics and stuff, but I have stuff around here that I'm still working. I have a 3D printer that I built. I didn't design it myself, but I followed somebody else's design. I'm still working on that. I have this small development platform. This is, what is it called? A D1 Mini. It's an ESP8266. Focus. These things are pretty awesome. They're super powerful, like way more powerful than an old Arduino, and they have built-in Wi-Fi. So I was using this to create a tire pressure monitor sensor for my car, because why did I need that? Oh, because I thought that the one that was built into my car wasn't working properly anymore. It's actually working. I just needed to pump up my tires a little bit. But so I started building this to read those sensors. Like, there's so many fun things that are out there, and I just recommend getting your hands on hardware. It's cheap these days. Like, you can go on AliExpress and get 10 of these for $5 or something like that. Like, it's so cheap. So get out there, get the hardware in your hands, buy a cheap soldering iron if you need to, and just start working. That's one thing that actually, you know, helped me on my way as I was learning to code. I was given the opportunity. There used to be this platform called the Butterfly, which was a precursor to the Arduino. It was a small AVR, and it had an LCD screen on it and a few buttons and like a little buzzer. And my dad got me that one year for my birthday or Christmas. And you know, I started using GCC and compiling AVR code on that. This was before Arduino, right? There's no Arduino IDE, but these days it's easy. So I just recommend getting out there and getting the hardware so you can do it.
Very interesting.
We've been mailing out robotics kits to all our members for them
cool.
to practice recently over the pandemic, since we can't meet in person.
That's great. What kind of kits do you have?
They're mostly Arduino kits with just various different sensors, different projects we give them as well, so they can practice.
That's great. That's awesome. My family's home. Yeah, let's see. Did I answer questions so far? Yeah. I guess getting back to JPL. Okay, here's another question. Did you have to get certified before working at JPL? There's a background check that you have to go through. That's like a US government thing, but you don't need any certifications, external certifications. Like, they'll hire, they'll hire anybody. Justin's working there part-time, but my guess is when he graduates, he'll be offered a full-time position. You can also just jump in right after graduating. We've had a lot of people do that, so yeah. What challenges have I faced throughout my career, and how did I overcome / handle them? So some of the big challenges that we face are setbacks due to all kinds of things and deadlines. And there's also, more personal challenges. For example, we had someone on our team who was hired as an APT and then became full-time, who passed away. And, she was young, only 21 or 22 when she passed away, and we were all really good friends with her. And so that was really hard for our team to overcome. But that's the kind of thing that's going to happen in your life no matter what. And so it's important to just remember that the work that you're doing is important, that your family's important, that your friends are important, and stay close to them. As far as the other challenges, such as deadlines, these things can be incredibly frustrating. So if you get close to a deadline, what starts happening is all of the managers start talking to you. So before the deadline, you're just working, you're making lots of progress, and then suddenly all these managers want to talk to you, and they start scheduling meetings, and you need to go to all these meetings, and you need to report to them. And so your progress slows. It's really counterintuitive, but it's really what they like to do. But one project I actually want to highlight is the, what was that called? Oh my gosh, I'm having a blank. But it was the Marco radio. There were two of them, Marco A and Marco B. And these were two small radios that actually went to Mars. They followed the InSight lander, and their job was a technology demonstration to show that CubeSats could do the job of larger multi-million-dollar missions. And so we had a small team that worked all summer. We worked overtime all summer. And it was like for about a period of 6 to 8 months. It was a very short project, but we were able to build these radios, and they actually completed their mission successfully. They did a flyby of Mars as InSight was landing. And for anything that lands on Mars, you have what's called EDL, entry, descent, and landing. And typically you have the Mars Reconnaissance Orbiter that's always orbiting Mars that can relay that information back to Earth. But sometimes the MRO is on the other side of Mars as you're landing. And so you don't get that real-time information. You have to wait till it comes back, and then the lander, if it survived, can beam back the telemetry. But what we wanted was some real-time information. So we sent these two satellites as InSight did its EDL. It was able to capture that signal and within its FPGA, repackage it and re-encode it and send it back out on a different RF link. So S-band is the communication that we use. That's the VHF frequency, 350 megahertz or so. And then we sent it back out on an X-band antenna that deployed. So that was a really fun project, but it was a really high stress, you know, just working long hours on it, but it was rewarding in the end when it worked. Let's see, we're getting a few more questions here. What programming languages are most used at JPL? It varies widely. We still use C for low-level embedded things. C++ is used a lot. Java is used a lot on ground processing systems. On the FPGA side, we prefer to use System Verilog or Verilog. Everybody uses Python. Many people use MATLAB. Some people use R. There's all kinds of different languages in use. But basically, if you have a preferred language, you'll find a way to use it at JPL. What advice would you give to your younger self at the start of your career? That's tough. I'm not sure. I guess the advice I would give is to not procrastinate. I'm sure some of you are familiar with procrastination, but it's a problem that I had as I was younger, and I still have today for certain tasks, especially in school. It was pretty tough for me. And so I would say just work on things slowly, a little bit at a time, and eventually you'll see progress there. Any other questions? We still have some more coming in. What would you say helped you the most in getting into JPL? Okay, so this is actually a pretty interesting story. So I started at Cal Poly Pomona in 2000. Where did I start? Oh my gosh. 2005. Yeah, I started in 2005, and I went to school for a year. But I'm a member of the Church of Jesus Christ of Latter-day Saints, and as part of our church, we typically go on 2-year missions when we turn 19. And so I'd gone to school for a year, and as I was going to school, I met Professor Rogstad. I took his C++ programming class. And while I was in that class, he said, Cameron, like, you already know this stuff. You should come work at JPL. So that's basically how I got it in. But I said, Professor Rogstad, I would love to, but I'm actually going to leave for 2 years on a mission. And so he said, okay, well, find me when you get back. And so I left for 2 years. I get back, and the first semester back, it was quarters back then. So the first quarter back, I'm walking in building 9 on the top floor, and he sees me from across the hall and says, Cameron, you still interested in that job? So somehow he remembered me for 2 whole years while I was gone in New Caledonia, serving a mission. He remembered me and offered me the job. And I said, Yes, because right when I got home from my mission, I needed a job. And so I started working at a friend's manufacturing facility where he owned some CNC machines. And so my job was just to put parts in, take them out, deburr them, put parts in, take them out, deburr them. It was a very repetitive, boring process. And so I was really happy that he offered me that job so that I could start working at JPL. Oh, yeah. So I haven't visited CPP campus recently. I've driven by. It's always nice to drive by and see the buildings there, but I haven't been in a long time. How are things there? Is everybody having a good time? I mean, have classes opened up yet?
I think it's been a year since we've been back. Yeah, since last March.
Awesome.
What was your favorite, as an EE major, what was your favorite lab back then?
Oh,
Anything that stands out in particular?
my memory is really bad, so I'm gonna misremember these names, but I think I really liked, I think it was, I forgot who did it, but the intro to FPGA and then the advanced FPGA.
Mhm.
That was with Sako, I think. And then with Professor Chang, James Chang, I did advanced RF communications. That was one of my favorite ones. I actually did an elective with him where I think you're allowed to like get an extra project. I needed an extra quarter, an extra, you know, what are they called? A point to graduate.
Extra unit? Mhm.
Yeah, unit. Yeah, thank you. And so I said, hey, Professor Chang, can I do a special project with you? And he said, sure. Like, what do you have in mind? And so I said, well, I want to build a brushless DC motor controller. And so I, designed the circuit board. And what did I even use for that? Did I use Altium? I might have done it in off time at work and used Altium. And I had the circuit board made. I soldered up the, everything, all the chips on there and created a brushless DC motor controller. That was pretty cool.
Awesome.
What is a brushless DC component though?
Oh, brushless DC is the type of motor that is in all like RC aircraft. It's basically a motor that instead of having brushed commutators as it spins, I don't have one within reach, but normally in a DC motor, you apply DC voltage, and the way that the motor works is it switches phases through brushes and contacts on the rotor. And so as it spins, the electricity will be going through one side and then the other side because there's contacts on the rotor that change. But a brushless DC motor doesn't have any parts that can wear. It switches phases by the electronics. And so you have fixed permanent magnets and electromagnets, and you just rotate those. And the speed that you rotate them electronically is what actually the shaft rotates at. So they're super useful in robotics applications. They can deliver, you can get ones that deliver a lot of speed, such as for RC aircraft. You can also get ones that deliver a lot of torque. You can get one, they have ones with, 20 or more poles, which are, different degrees that you need to rotate through or cycle through to rotate the whole motor. And that gives you tons of torque. And so you can create really strong robotic arms and other things. Yeah, I'm just trying to think of what I can share with you that's interesting. Oh my gosh, I don't know.
Cameron.
Yeah.
Something that a lot of us have faced, going through school online is like we have to balance school and things, and sometimes you burn out, right? What are some fun things you do on your off time that helps you with that burnout?
Oh, I'm lucky. I have a 2-year-old daughter. She's pretty fun. But I guess, so usually what happens when you burn out is you just kind of want to veg, right? Like you get in, I just want to watch Netflix or YouTube. I just want to do nothing. For me, I think that the thing I need to learn to do better is to do things and realize that the things I'm doing are rewarding for their own right. So like I can tell myself, okay, if I just program this one part, this one function and make that work, even though I'm not going to finish the whole project, like if I can just do this one part, then I'll be happy. And it's important to say that before you start, because otherwise, like you program it and you're like, oh man, I'm still not done. And you get burned out. So yeah, just set those small goals, like Allison says, and be happy that you accomplished them. Yeah. But if you're really, really feeling burned out, I think it's important to take a step back from your work and focus on something else. Maybe you like volunteering, or maybe you like to ride bikes, mountain bikes, skateboarding. Or maybe it's a fun side project like this, or a 3D printer. I built an electric skateboard. To build the electric skateboard, I needed to first build a battery spot welder, so I built that. There's so many different things that you guys can do. Don't get so burned out that you think that everything is a chore or everything is not very fun anymore. Open your minds and realize that there are so many opportunities. And maybe it's nothing to do with what you're studying at school. Like maybe you want to write a book, or maybe you want to write a comic book. Like there's so many different things you can do. Yeah, CPP, I was involved in, I think you guys normally have pizza at your meetings, right? Yeah, so I stopped by the robotics club for pizza. I don't think I ever really helped out too much there, but I was involved in the, it was like the cybersecurity club. I forgot what it was called, but I've always had a fascination with cybersecurity, and so I was involved there. Oh, I also got a physics minor. So I did an electrical engineering major and a physics minor. That was really fun.
So Allison asks, were you involved? Oh, I think you just answered that.
That's what I just answered. Yeah.
Anthony asks, is working overtime a common thing in JPL? I think it's pretty relevant right now.
What's that, Justin?
Oh no, I think everything's on crunch right now.
Yeah, especially in our group, right? The cool thing is, if you first start at JPL, you're what's called a weekly employee. And is that right? Or maybe I get them backwards.
Yeah,
anyway,
weekly employee.
Yeah, you're the type of employee where you have to fill out your time card and you put in the hours that you work every day. So it's really easy to get overtime. If you ask the project manager, hey, I'm actually going to work a little bit of extra on this, can I work overtime? Then you can. But after you become a salaried employee, then you just put in percentages that you worked for the whole week. So to get overtime, you need to fill out what's called an extended work week application. And this takes a couple weeks to set up, and you need to be able to stay on EWW for a couple months. So it's not like you can just pick up a few hours here and there. You actually have to work 8 extra hours per week for a couple months. So it becomes a lot, but you know, I'd say like maybe 20% of the people at JPL are working extra hours, depending on what projects are going on. Right before the launch of Perseverance, there was like maybe 50% of the people working extra hours.
Barbara asks, how did you survive majoring in EE and minor in physics? Yeah.
Oh, I don't know.
Built different.
And how did I need the extra? Why did I still need the extra unit with Professor Cheng? I don't understand.
I don't know. Yeah.
That's a good question. Yeah. I think part of it was just my background. Going to Cal Poly and studying electrical engineering just fit like a glove for me. My dad's an electrical engineer. I've done, you know, hobby electronics since I was a kid and programming. So that really helped me. And I've been fascinated with physics as well. And so, yeah, it was just something that kind of fit me very well. I'm trying to think of some other reasons it's fun to work at JPL. There's funny people there. Like there's eccentric people there. I have one friend. We'll call him Tommy. So he remains anonymous. But basically, Tommy is a very funny guy. he's very forgetful. For example, we were working in the lab one time, and you have to wear ESD wrist straps. And so these are just wrist straps that have coils and connect to the ESD safe mat, that's electrostatic discharge. And so it just makes it so that you don't shock things as you're working on it and damage components. So he was wearing this and he didn't remember. He was working on his computer and he realized he had to go do something. He said, "Oh no, I gotta go do something." So he runs away and gets pulled back because he's connected on that wrist strap. That was really, really funny. The other time was, this is with the same Tommy. He like walks very fast and kind of talks to himself sometimes because he's very brilliant, but like just, eccentric. And so he was walking very fast and talking to himself, and he didn't hear like the guard say, "Where's your badge? Where's your badge?" And he was walking into lab and he forgot to show the guard his badge. And so he just walking. The guard runs and tackles him to the ground. And then he's like,
Oh, man.
My badge is right here. So that's a really funny story. That doesn't happen a lot, so you don't have to worry about getting tackled to the ground. As long as you show your badge as you walk in.
Interesting.
Yeah, exactly. So yeah, that's some funny things. Part of the commute. So there's really cool. So when lab is open for on-site work, there's really cool talks, and these are happening virtually too. But every week there's tons of different talks and different classes you can take to learn more. So I'd recommend everyone to engage in those things. And I appreciate that all of you are here today, because it's these extra things that can really expand your horizons and help you to, do your job better and avoid burnout as well. It's kind of like taking a little bit different parts of your life and spreading out a little bit. Justin, any questions?
Yeah. So we have a couple of foreign nationals who are taking classes at Cal Poly.
Oh, I think you're muted.
Oh, can you hear me? Hello?
I can hear him. Can you hear me?
Let's see. Let's
Oh,
see.
okay. I'll put it in the chat.
Hold a Jimmy here and disconnected my. It was my fault.
You're good, Cameron. So we have a couple of foreign nationals taking classes at Cal Poly, and I was wondering if you work a lot with foreign nationals, if you work a lot with people internationally. What is your experience with that?
Yeah, we have quite a few foreign nationals on our group. It's kind of hard at JPL to be a foreign national, unfortunately. They have separate network access. So this is getting better slowly, but there's separate wikis, and usually foreign nationals have trouble like accessing information. But we have a lot of foreign national scientists that we work with that work at JPL as postdocs. And we also work with foreign governments. For example, we worked with Taiwan to implement Cosmic 2, which is the weather forecasting satellites that are orbiting the Earth right now. So they do radio occultation measurements. I guess I really haven't talked about that much. So the radio occultation measurements are, an occultation is when something obscures something else. So so what happens is you have this satellite that's orbiting the Earth, and it's looking for GPS satellites. It's receiving signals from GPS satellites. As this GPS satellite's set below the horizon, that signal actually bends a little bit around the Earth because of gravity. And so we're able to see things within the actual structure of the clouds and the ionosphere and the sky and everything. And so we can predict weather that way. We can actually see precipitation and other things like space weather events. So Cosmic 2 was a mission where we implemented this for the Taiwanese government. They're the ones that paid us to do it. We also have, other missions that the Air Force pays us to do because they're interested in space weather, and that's weather that happens above the ionosphere in like layer F or G. Oh, totally Vim. Yeah, Vim all the way. You knew that.
For those who don't know Vim, do you want to explain a little bit about Vim and TMX?
Oh, sure. I mean, Emacs is fine too, but basically, what I've taught Justin to do over the last year is set up kind of a persistent work environment on our different build servers. So what we can do is we can SSH in. SSH is secure shell. So you open up the terminal on your computer. If it's Mac, it's just called terminal. If it's Windows, you need to download WSL or
subsystem
or PuTTY. But yeah, so you can SSH into the server, and there's a program called TMX, which stands for Terminal Multiplexer. When you run this, it opens up a new window. Well, the same window, but it puts a bar at the bottom and a little 0, meaning that you're in terminal 0. So what you can do is key combination. I have it set to Control A. So I do Control A and then C for create, and that will create a new window. So I can have multiple windows within my same terminal. And the cool thing is if I just close my MacBook or turn off power or put my computer to sleep, when I bring it back up, I can SSH back in and I can type tmux space attach or just tmux space A, and that will bring back my complete session. So that's super helpful when you're working remotely. You don't lose all of your data. I just used this recently to update my computer at home, and now I have all my windows back up where I left them.
Allison asked, do you have any course advice for people that are just getting into industry, like to prepare for an intern position?
Yeah.
It's been a while.
I guess, yeah, it's been a long time, but I've also seen, interns come into JPL. I would say just keep trying. If you don't get selected the first time, just keep applying. And if you have specific skills and specific things that you want to work on, you can sometimes find public contact information for people that are in that field at the place you want to work. And sometimes it's useful to reach out to them. Don't spam them, but just say, hey, I'm looking for a job. I have these great skills in this area. And maybe they'll be able to put your name to the HR department. Because the problem these days, it's like everything passes through HR. And so sometimes HR doesn't properly screen the applicants. So you get HR disregarding a lot of people that are actually very qualified and that the engineering team would really like to talk to, but for some reason we never get a chance. If you can ever hand your resume directly to an engineer, that's always the best route, because they'll be able to promote your resume to whatever team member needs to see it.
Can we hand out our resume right now to you?
Yeah, if you want to email me your resumes, I'll see what I can do. Yeah, for sure. Justin can give you guys my email.
Yeah. Would you like them to send it to your JPL email, a separate email?
Yeah.
JPL?
Yeah, JPL.
Okay.
Yeah.
You guys have any other questions, comments for Kameron?
Maybe I have a question. Is Justin a good worker?
I gotta go, actually.
Justin's great. Yeah, he's a quick learner. Yeah, it's awesome to see the progress he's made since he started here. And I really, truly mean that, Justin. You've been a really good asset. You take on tasks and you try to dive deep and really learn, the full meaning of what you're working on. You try to understand the tools that you're using. It's really impressive.
Thanks, Kameron. Well, I have a good mentor.
Thank you.
Let me drop Kameron's email real quick. Here's another question. What did you do at work yesterday? Just a day in the life.
Oh, yeah, that's a really good question. Oh, man. I wish I could show you. Let me think. Can I show you some stuff? So a lot of my time these days is spent answering questions for other team members. I sit down with them on phone calls or just back and forth via email on Slack, JPL Slack and WebEx, and we kind of go over problems and answer questions together. So I usually try and start my day by working on a task that I'm responsible for, something that I know I need to do. Because in the morning, I feel like I'm a little bit sharper. I'm able to just get started and start programming or solving problems. So yesterday I was working on a problem where our root file system on one of our boards wasn't working. It was something it was a board we tested before, and it used to be working just fine. And I went to update the root file system because we'd made some changes. For those who don't know, a root file system is all of the files on a Linux system, basically all of the applications, all of the libraries, all of the support files, everything that goes into a Linux system. So it's called root file system because on Linux, instead of having C: or D:, you have just a slash, and that means root. So the file system looks like slash, a folder, another slash, and another folder. So the root file system wasn't updating correctly. I would update it, and then I go to reboot the computer or the small board, and I would get a kernel error saying that your file system isn't what I expect. It's corrupted for some reason. So I was scratching my head all day yesterday trying to figure this out. And of course, I don't spend 8 hours trying to figure this out, but I was thinking about it for 8 hours. But I had other meetings and other things that I needed to do. And so this morning, I go and look at it. I'm like, oh, I forgot that I needed to actually completely wipe the higher layer of the partition before I, updated the lower layer. And so I did that, and it worked first time. And then after that, I had a meeting to solve a crisis with our partners at Goddard. We're working on what's called the Project Snoopy, and that is going to be measuring reflections from a Navy communication satellite called MUOS. And we're going to be looking at reflections to determine things like soil, moisture, content, snow, water equivalent, that kind of thing. So they had a crisis where they didn't quite understand something I'd said. And so I had to have a meeting with them. While that meeting was supposed to be starting, my other teammate called me with a question. And so I was answering him while I was trying to join a WebEx meeting. And then right after that meeting finished, I joined here. So yeah, it's been busy. Let's see, I have a question here. How would you balance your schedule if a task requires you to work with others? This one's a really good question. Sometimes you need to set aside a day. So some people on lab, they set aside Fridays. Every Friday is their personal time. They're not going to go to any meetings. They're not going to accept any questions that day. They're just going to work that day by themselves. And sometimes what we do just to make sure that happens is we go on our schedules and we block out the complete time. And then that way, anyone who's trying to schedule a meeting sees that we're busy during that time. So I haven't really had to resort to that. But what I do is probably not the best thing. I just work late. So I should probably start managing my time a little bit better. But like recently, it's been so busy. I've been working like 12-hour days. Even Fridays that we have off, we have every other Friday off at JPL. We normally work 9-hour days. But I've been working those Fridays, some Saturdays. It's been quite insane.
Yeah, thank you for taking the time to come out and speak with us.
Oh yeah, I know.
Busy schedule.
Yeah,
thank you very much.
Invited me a while
Thank you
ago.
so
I'm glad I could.
Yeah,
I'm very glad.
thank you. So we're about to wrap things up. We can take 1 or 2 more questions, and then I think we'll call it a day.
There's Theo. She's our little 2-year-old girl.
Hi, Theo.
Theo. Hi. Yeah, so Any other questions?
Speak now or forever hold your silence.
Or follow up with me if you have very specific questions
Yeah.
via email. I'll see what I can answer. Electrical engineering, has my daughter shown any interest? Actually, she does. She loves to help me work on my 3D printer. She'll hand me screws and the tools that I need. It's really fun. She's working on a brushless DC motor.
She's real lucky.
She is, yeah. She's a really good girl. Yeah, you guys are doing the right thing. Like, some people go through school without joining any clubs, without participating. You guys are in this club. You're participating in the meetings, the extra meetings. Like, that's the key to success. Don't beat yourselves up because you feel like you're not at the level you want to be. You've made progress. Look at it, look at the last year. Like, even in a year, like, think about what you know now that you didn't know then. Think about what you know now that you didn't know in high school. Like, you're making so much progress, and don't feel bad because of the things you don't know. Feel happy because of the things you know now.
We came for the pizza, but thanks, Cameron.
Unfortunately, there's no pizza.
Yeah.
Not today.
Yeah, well, thank you, Cameron, for coming today. Thank you so much for taking the time out of your day to speak to us. Yeah.
Yeah, thank you.
Thank you so much, Cameron.
Nice to meet all of you, and I'll check your resumes, and I look forward to any more questions you might send me via email.
Thank you very much, Cameron.
All right, thank you,
Have a
Cameron.
good day.
All right,
Right.
goodbye.
All right.
Have a good
Have a
one.
good day.
Have a good day. Bye-bye. All right, everyone.
All right.
The meeting is officially ended.